everybody. In this video, we're going to be talking about sample spaces and choice trees, which are some tools that we'll use to help make our more complicated probability problems a little bit easier to think about. So take 3 deep breaths and let's make this math easy. All right, so when we're talking about the sample space, a sample space is basically a list of all of the possible outcomes that you could have. So for example, if you were rolling a 6-sided dice, your sample space would be pretty simple. You would just say, okay, well, it's a list of all the possible outcomes. So I would have a 1, a 2, a 3, a 4, a 5, and a 6. And that would be the list of all of the things in my sample space. Now, if you were doing a more complicated situation, like let's say you were flipping a coin, but you were flipping it twice. Well, in that case, your sample space would be the possibility of rolling 2 heads, or you could roll a head and then a tail, or you could roll a tail and then a head, and then your last one would be rolling a tail and then a tail. So depending on how many events you have happening, your sample space can sometimes get quite complicated, because this one was pretty simple because we just rolled a dice once. And this one also wasn't too bad because we only flipped a coin twice. But if you were to roll a dice and flip a coin and spin a spinner, and you had like 3 events going on, the list of all of the possible outcomes would be pretty long. And one of the ways that we can use to help us organize this in our head and understand how big the sample space is with choice trees. So the easiest way to see how a choice tree works is to see an example of this. And we actually did choice trees a little bit in our graph theory unit, but we'll be diving deeper into it in this unit. So the way that you build a choice tree is you basically make a layer of branches for each choice that you're making. So if I wanted to flip a coin 4 times, I'm essentially making 4 choices. Because the first time I flip the coin, I'm going to have 2 choices for what could happen. I could either flip a head or I could flip a tail. Those are my 2 choices for the first time I flip the coin. But I'm not just flipping the coin once, I'm flipping it 4 times. So then I say, okay, well, if I flip the coin again, then I have 2 options again for what could happen. And so I branch those 2 options off of each of my previous options. Then I say, okay, well, that's my second time that I flipped the coin. Well, the third time I flipped the coin, I still could either get a head or I could get a tail. And so I branch that off of each of my previous options. So each layer of branches represents a choice that's happening. And the last thing I need to do is I need to say, okay, well, let's say I flip a head and then I flip a head and then I flip a head. Well, I'm trying to flip my coin 4 times. So that means I need to make another layer of branches. And when I do that, that's going to give me a choice tree that represents the entire sample space of what could happen if I flip a coin 4 times. So I'm sorry, this is taking quite a long time to write this out. But this would be the choice tree that represents a coin being flipped 4 times. And the way that you would turn this into a list is basically each one of the end branches represents a possible outcome you could get. So this branch, for example, represents getting a head the first time, a head the second time, a head the third time, and a head the 4th time. So if I was listing out a list, this would look like one of my possible outcomes. Then this one would be very similar. I would get a head and then a head and then a head, but my last coin flip would be a tail. Then this one would be a head, and then a head, and then a tail, and then a head. And this is because I basically just track this branch all the way back down to my original choice. And so I go through a head, a tail, and then a head. So then this one would be a head, a tail, and then a tail. And basically you would go through and write the list out for all of these end branches. So whenever you do a choice tree, each of the end branches represents one of the outcomes in your sample space, and the way you write it down is you just trace it all the way back to the first choice. So like this one right here that I circled in red would represent head, tail, head, head. And you could list out the sample space, and in this case, because there are 16 of the end branches, then that means that my list would have 16 things in it. And you can count the number of things in a sample space without having to list them all out. Because if you look at how this choice tree was built, you'll notice that there's a mathematical pattern to it. Because in our first choice, we started off with 2 choices because we had heads and tails. And then for our second choice, we also had 2 choices, but those 2 choices were branching off of our previous 2 choices. And so we had a total of 4 choices altogether at the end of our second coin flip. Then again, we had 2 choices for our third coin flip, and those 2 choices were branching off of each of our previous 4 choices. And so then we had a total of 8 choices altogether. And then for the last one, again, we had 2 choices. And you'll notice that if you do 2 times 2 times 2 times 2, that equals a total of 16 possible outcomes. And you can see that we do have 16 end branches in our choice tree. And so you can write out the mathematical expression that tells you how many possible outcomes there are. And you don't necessarily have to write out the whole sample space. So in your assignment, you will be writing out the entire sample space, and you'll be listing it out like this, just to practice understanding what the choice tree means. But later on in this unit, you'll be using more mathematical calculations to figure out the number of possible outcomes. And you won't necessarily be drawing a choice tree for all of them, because some choice trees can be really, really big. So to wrap up this video, why don't you guys go ahead and practice this one. So let's say that a couple plans on having 3 children, and each time they have a child, they'll either have a boy or a girl. And I want you guys to draw a choice tree that will represent the sample space of this couple having 3 children, as well as actually listing out what the sample space is and calculating the number of things in your sample space. So pause this video and do those 3 things. So make a choice tree, list the sample space, and calculate out how many things are in the sample space. So pause the video and do those 3 things, and then restart it to see how I would solve it. All right, so the first thing I would do is I would list the options for what will happen when this couple has their first child. So their first child will either be a female or a male, so I'll list those out. And then I'll say, okay, well, if they have a female, their second child could either be a female or a male. Same thing if their first child was a male. So for the second child, the 2 options are branching off of the previous 2 options. Then I would say for their third child, which is the third layer of branches of the trees, again, it would either be a female or a male. And it would look kind of like this. And so if I wanted to list out the sample space, basically I just need to take each of the end branches and trace it back to see what outcome that represents. So in this case, this first one represents having all girls. Then this one represents having 2 girls and then a boy. This one represents having a girl and then a boy and then a girl. This one represents having a girl and then 2 boys. Because again, I'm tracing this back, and that the first child was a female, the second child was a male, and the last child was also a male. So that's how I got that. Then this one would be a male and then 2 females, and then a male and a female and a male. That would be this one. And then a male, male, and a female. That would be this branch. And then the last one would be having all boys. And so this list right here would be the sample space of a couple who's planning to have 3 children. And one way that you could calculate the size of that sample space is you could look at how many choices there were in each layer of the choice tree. So in this first choice, there were 2 choices, either a female or a male. And then those branched off into 2 more choices, which then branched off into 2 more choices. And so the way I would calculate this is 2 times 2 times 2, which equals 8. And you can see that there are indeed 8 possible outcomes in the sample space. So I hope this video was helpful, and I hope you guys enjoy your assignment listing out the sample spaces. And if you have any questions, let me know.